This is your review for your 3x3 systems test. The first problem that we start off with is two matrices, and we want to add A and B together. So 3 plus 2 is 5. Negative 1 plus negative 2 is a negative 3. 4 plus 3 is 7. And 2 plus 0 is 2. Then our next one is 2b. So we're going to multiply every element in B by 2. So I'd get 4, negative 4, 6, and 0. And then I have A minus 2b. So 3 minus 4 is a negative 1. Negative 1 minus a negative 4. Well, minus a negative changes to plus. So negative 1 plus 4 is a positive 3. 4 minus 6 is negative 2. And 2 minus 0 is a positive 2. And then I want to find the determinant of B. So that's my main diagonal, 2 times 0, which is 0, minus my other diagonal, and 3 times negative 2 is a negative 6. Minus a negative changes to plus, and the determinant of B is 6. My next two questions are systems of equations questions. Number 2, a farmer raises corn and soybeans on 350 acres of land. Because of expected prices at harvest time, he thinks it would be wise to plant 100 more acres of corn than soybeans. How many acres of each does he plant? Set up a system of equations to solve this problem. We know that corn plus soybeans has to equal 350. And we know that he's going to have more corn than soybeans, 100 more acres of corn than soybeans. Then we're going to solve this. Well, we can solve this with substitution by plugging 100 plus S in for C. So we'd have 100 plus S plus the number of soybeans is equal to 350. When I combine like terms, I end up with 100 plus 2S is equal to 350. I'm going to subtract 100 from both sides. So 2S is equal to 250. Divide by 2. So I know soybeans is 125. And I know corn is 100 more than that. So 100 plus 125 is 225. So he has 225 acres of corn and 125 acres of soybeans. Number 3, you have 85 coins in nickels, dimes, and quarters with a combined value of $13.25. I had a little bit of extra junk whenever I was typing. There are twice as many quarters as dimes. Write an augmented matrix to represent this situation. So we know that we have nickels, dimes, and quarters. So nickels plus dimes plus quarters is equal to 85, because I have 85 total coins. Now I know that they have a combined value of 13.25. Well, a nickel is worth 5 cents, so that'd be 0.05 N, plus, and a dime is worth 10 cents, so 0.10 D, and quarters are worth 25 cents, so 0.25 Q, and that's going to equal 13.25. My next equation is that there are twice as many quarters as dimes. So quarters is equal to 2 times dimes. Well, I need to change this so that I can put it into my matrix. So I'm going to subtract 2D from both sides. And I have 0 nickels, a negative 2D, plus Q is equal to, and if I move my 2D over to this other side, I have 0 left. So my matrix would be 1, 1, 1, 85, 0.05, 0.10, 0.25, and 13.25, and then 0, negative 2, 1, and 0. I'm going to put this in my graphing calculator to solve, so I'm going to go second matrix. I want to go over to edit. I'm going to type in a 3x4 matrix, and then I'm going to enter my data in 1, 1, 1, 85, 0.05, 0.10, 0.25, and 13.25, 0, negative 2, 1, and 0. Once I get all my data in, I'm going to press second quit. Then I'm going to go back second matrix, over to math, and I want to choose RREF. And I want to perform that with matrix A. So RREF and then choose matrix A. And that tells me that I have 25, 20, and 40. And those are in the same order that I put my variables in. So I did nickels, dimes, and quarters. So I know that I have 25 nickels. I have 20 dimes. And I have 40 quarters. Number 4, which quadrant of the coordinate plane contains no solutions of the systems of linear inequalities? So I've got 3 inequalities over here. I have y is greater than or equal to 4x plus 1. So I know that has a y-intercept of 1, and it goes up 4 for every 1 it goes over. It's going to be a solid line because it's an equal to, and it's going to be shaded above because that's where it's greater. My next one, I need to change to slope-intercept form. So I'm going to subtract 2x from both sides. That gives me y is less than negative 2x plus 5. So it has a y-intercept at 5. 1, 2, 3, 4. I should have gone up 1, 2, 3, 4 to right there on this line. So my y-intercept of 5, and then it has a slope of negative 2. So it goes down 2 and over 1. Down 2 and over 1. And this is going to be a dotted line. And this is less than, so it's going to be shaded below here. And then my last one is y is greater than or equal to negative 3. So I go down to negative 3 and I draw a horizontal line. And it's above here. So the area that's been shaded every time is this part right over here. Well, I can see that it's obviously in quadrant 2. It's got a little bit in quadrant 3 and a little bit in quadrant 1. So the only quadrant that isn't represented is over here in quadrant 4. So it has no solutions of it in quadrant 4. Number 5, solve the following systems of equations. Be sure that you can solve these both algebraically and using matrices. So matrices was what we did up here on number 3. I'm not going to demonstrate those with matrices again. I will demonstrate those algebraically. So we need a little bit more room to work. I'm working with the one on the far left right now. So x minus y plus z is equal to 6, and negative 4x plus 3y plus 2z is equal to 12, and 2x minus 2y plus 2z is equal to 8. Looking at this, I can see that there's some similarities between my first and third equation. So I'm going to go ahead and write my third equation down. 2x minus 2y plus 2z equals 8. And I'm going to multiply my top equation by negative 2 so that some of my terms will cancel out. When I multiply this by negative 2, I get negative 2x plus 2y minus 2z is equal to negative 12. My x's will cancel, my y's will cancel, my z's will cancel. I'll end up with 0 is equal to negative 4. This is never true, so there's no solution. I call this A. Moving on to B. With B, I can see that my second equation doesn't have a z term. So I'm going to solve this for x because it only has 2 terms, and I'm going to substitute that into my other 2 equations. So equation 2, if I solve that for x, I would do that by adding 2y to both sides. So that gives me x is equal to 2y plus 5. And I'm going to substitute that into my first and third equation. So my first equation would be 2y plus 5 minus y plus 3z equals 6. And in equation 3, I have 2x, so I'd have to do 2 times 2y plus 5 minus 2y plus 5z equals 9. One on the left, I'm going to go ahead and combine like terms. So 2y minus y is just a y, plus 5 plus 3z equals 6. Then I'm going to subtract 5 So y plus 3z is equal to 1. Over on the right, I'm going to distribute. So 4y plus 10 minus 2y plus 5z equals 9. 4y minus 2y is 2y. So 2y plus 10 plus 5z is equal to 9. I'm going to subtract 10 from both sides. So I have 2y plus 5z is equal to negative 1. Then I'm going to solve this equation for y by subtracting 3z from both sides. So y is equal to 1 minus 3z, and I'm going to substitute it into this equation for y. So I'll have 2 times 1 minus 3z plus 5z is equal to negative 1. 2 times 1 is 2 minus 6z plus 5z is equal to negative 1. Combine my like terms. I have 2 minus z is equal to negative 1. Subtract 2. Negative z is equal to negative 3. So positive z is equal to positive 3. I'm going to plug that in for y into this equation. Or sorry, first into z to solve for y. So I have 1 minus 3 times 3. 3 times 3 is 9. 1 minus 9 is negative 8. And then I can plug this into into this equation for y to solve for x. So x is equal to 2 times negative 8 plus 5. So negative 16 plus 5 is negative 11. So my solution is the ordered triplet negative 11, negative 8, positive 3. Flip over. Number C. I have 3x plus 2y plus z is equal to 20. Negative x minus y plus 2, minus 2z is equal to negative 2. And 2y plus z is equal to negative 1. I'm going to solve the third equation for z. So I would subtract. I have 2y plus z is equal to negative 1, and I'm going to subtract 2y from both sides. So that gives me z is equal to negative 2y minus 1, and I'm going to substitute that into my other two equations for z. So I have 3x plus 2y plus z, which is a negative 2y minus 1, is equal to 20. And in my other equation, I have negative x minus y minus 2 times z, which is negative 2y minus 1, which is equal to negative 2. My equation on the left, my two y's are going to cancel out, and so I'll have 3x minus 1 is equal to 20. Add 1 to both sides. 3x is equal to 21, so x is 7. Once I found x, I can plug it into this equation. So negative 7 minus y. Negative 2 times negative 2y is a positive 4y. Negative 2 times negative 1 is a positive 2 is equal to negative 2. So negative 7, negative y plus 4y is a positive 3y. Plus 2 is equal to negative 2. Going to combine my like terms. So I have 3y minus 5 is equal to negative 2. Add 5 to both sides. 3y is equal to 3, so y is equal to 1. So now I have x and y. I can plug those back into an equation to find z. I'm going to plug it into this equation right here. So negative 2 times y, which is 1, minus 1. Negative 2 minus 1 is a negative 3. So my solution is the ordered triplet. My x value is 7, my y value is 1, and my z value is negative 3. And my last equation, equation D. So I start off on this. I have x minus y plus z is equal to negative 3. 2x minus y plus 5z is equal to 4, and 4x plus 2y minus z is equal to 2. I'm going to solve this one using elimination. I'm going to add my third equation to twice my second equation to cancel out my y's, and then I'm going to add my third equation to twice my first equation to cancel out my y's. So I'm doing equation 3 plus twice equation 2. And I'm also going to do equation 3 plus twice equation 1. So equation 3 is 4x plus 2y minus z is equal to 2. And twice equation 2, so that's going to give me 4x minus 2y plus 10z is equal to 8. I'm going to add those together. My y's cancel out, and I end up with 8x plus 9z is equal to 10. Equation 3 over here is 4x plus 2y minus z is equal to 2. And if I multiply equation 1 by 2, I'd get 2x minus 2y plus 2z is equal to negative 6. When I combine these, my y's cancel out. I'm left with 6x plus z is equal to negative 4. I'm going to solve this one for z, so I'm going to subtract 6x from both sides. So z is equal to negative 6x minus 4. And I'm going to substitute that into this equation for z. So I'd have 8x plus 9 times a negative 6x minus 4 is equal to 10. So 8x, 9 times negative 6 is a negative 54x. 9 times negative 4 is a negative 36 is equal to 10. Combine my like terms. That gives me a negative 48x minus negative 46x minus 36 is equal to 10. Add 36 to both sides. Negative 46x is equal to positive 46, so x is equal to negative 1. Then I'm going to plug that in for z, into x and find z. So z is equal to negative 6 times negative 1 minus 4. So that would be 6 minus 4, which is 2. That is my z value. And then I need to plug those in to find out what y is. I'm going to do that into my first equation. So that is x minus y plus z is equal to negative 3. So negative 1 minus y plus 2 is equal to negative 3. So negative y, negative 1 plus 2 is a positive 1 is equal to negative 3. So negative y is equal to, when I subtract 1, I get a negative 4. So y is equal to positive 4. So that's the order triplet, negative 1, 4, and 2. Just realized I've been writing off the screen. I apologize.